Hello everybody, getting ready to do lesson 3.2 part 2 today, classwork for Algebra 1 Math. And on your classwork sheet you got 24 points. Students have that out ready to go. And you got 14 points to go into your notebook or your notebook guide. Have that ready. Graphing linear equations. Don't forget to put your name and date period on your tablet, your phone, your PC, your Droid, your Apple, your iPhone, your iPad, your Chromebook. Go to page 1 is a notebook entry here. Linear equations. A linear equation is an equation whose graph is a line, such as the equation in example 2. The standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. So, okay, that's cool. Consider what happens when a equals 0 or when b equals 0. When a equals 0, the equation becomes by equals c or y equals c over b. Because c over b is a constant, you can write y equals b. So that's kind of a fancy way. Similarly, when b equals 0, the equation becomes ax equals c or x equals c over a. And you can write x equals a in that. Standard form, define standard form, students. This goes in your notebook, page 3, 5 points. Define standard form. And let's go into our next example here. We have example 3, graph y equals b and x equals a. So graph part A here, y equals 2, and part B is x equals -1. For every value of x, the value y is 2. That's why it's just called y equals 2, because for every value of x, the value y is 2. The graph of the equation y equals 2 is this horizontal line right here, y equals 2. And then part B up here, x equals -1. For every value y, the value of x is -1. The graph of the equation x equals -1 is a vertical line, 1 unit to the left of the y-axis. This is the graph of x equals -1 right there. So up here, got to practice graph the equation x equals -4. And then down here, students, this is yours, y minus 2x equals 5. So let's write it up here, x equals -4. Here it is, x equals -4. It's a vertical line that goes through -4 on your horizontal axis. Okay, page 6, key concept here, equations of horizontal vertical lines, y equals b and then x equals a. So there it is. Those are your horizontal and verticals. The graph of y equals b is a horizontal line. The line passes through the point of 0b. So 0b. So when x equals 0, y equals b. And then there's your graph. And then over here, the graph of x equals a. X equals a is a vertical line. The line passes through the point a 0. So here it is, when x equals a, y equals when x equals a, y equals different amounts here, x equals a. So this is a vertical line, this is a horizontal line. Y always equals this number with various values for x. Okay, so linear functions. In example 3, y equals 2 is a function while x equals -1 is not a function. The equation ax plus by equals c represents a linear function provided b does not equal 0. That is, provided the graph of the equation is not a vertical line. If the domain of a linear function is not specified, it is understood to be all real numbers. The domain can be restricted as shown in example 4. And then we go page 8, linear function. Define a linear function, students, in your notebook, 5 points. Let's go into our next example. Graph a linear function, example 4. So graph the function y equals -1/2 x plus 4 with a domain x is greater than or equal to 0, then identify the range. So here's our table. Here's our domain 0, 2, 4, 6, and 8. And then here's our range 4, 3, 2, 1, and 0. So with that, plot the point. So to plot this is what your graph's going to look like right here. Y equals 1fx plus 4. We have a y-intercept up here at positive 4. And then you have a slope here of negative 1/2. And then here's your plots here. Looks like a 2, 4, and 6. And then 8. And then at 0. Connect the points with the ray because the domain is restricted. It's everything this side of the y-axis. And what else can we say about it? Well, let's see. The range from the graph, you can see that all points have a y-coordinate of 4 or less. So your range is decreasing here, 4 or less. So the range of the function is y is less than or equal to 4. So that is your range of that. Let's graph the function y equals negative 3x plus 1 with a domain of x greater than, or rather x less than or equal to 0. Then identify the range of the function, and then you have something down here too, students. Let's do our guided up here. Our guided graph the function y equals negative 3x plus 1. Here's our table here. When x equals 0, y equals 1, negative 1, 4, negative 2, 7, negative 3, 10, negative 4, 13, negative 4 to be 12, plus 1 to be 13. Okay, so there's your table. The range of the function is y is less than or equal to positive 1. Here's, I'm sorry, y is greater than or equal to 1. Okay, so we start here at 1, we go 4, 7, 10, 13. So that is our range down here. That's our range. What's the graph look like? Here's your graph. It starts here at 1 and it goes up to the left like that. Negative 3x plus 1, or actually they call this a negative slope here. So we have a negative slope from left to right. It's got a negative slope of negative 3, and then here's your y-intercept. And that's your lesson for today. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.